All right, let's talk about a huge idea at the very heart of how we think AI learns. It's something that most of us, even people in the field, just take for granted. But it turns out a really important paper suggests we might have been getting it wrong, like completely wrong this whole time.
So let's start with a concept that just feels like common sense, right? Interpolation. At its core, it's just connecting the dots. You have a bunch of known data points, and interpolation is just the process of figuring out what lies between them. Super intuitive. And it's basically the foundation of how we assume all learning works, including for AI.
And this leads us to this really core belief we have about AI. The reason these massive, state-of-the-art models work so incredibly well is because they are just masters of interpolation. They've seen so much data that they can navigate the space between all those examples perfectly to find the right answer. Makes perfect sense, doesn't it?
But here's the twist. What if that whole idea, that really comfortable assumption about connecting the dots, is just not true? What if, when we get to the massive scales that modern AI operates on, something totally different is going on under the hood?
This brings us to the paper that's at the center of today's explainer. We're diving into a 2021 piece of research that basically throws a giant wrench into that nice, tidy picture of how AI learns. The paper's called Learning in High Dimension Always Amounts to Extrapolation. It's by Balestrillo, Picenti, and LeCun. Now, if you follow AI at all, that last name, LeCun, is a really big deal. We're talking about Yann LeCun, one of the godfathers of deep learning. So when he puts his name on a paper making a claim this big, you gotta pay attention. And the paper's central claim is, honestly, it's a shocker. It says, and I'm quoting here, on any high-dimensional data set, interpolation almost surely never happens. Just let that sink in for a minute. Not that it's rare, not that it's uncommon, it almost surely never happens. So the authors are really taking aim at two of our most fundamental beliefs. First, this idea that AI is successful because it's good at interpolating. And second, the simple idea that interpolation is even a thing that happens very often in AI. The paper basically says both of those ideas are myths. Well, think about it. If you give a model a new piece of data and it's not finding a home for it in between the points it's already seen, there's really only one other possibility. Right? It has to be working outside the known boundaries of its training data, and that is, by definition, extrapolation. This completely flips the script on how we thought this stuff worked. So how in the world could this be true? How could AI always be guessing outside the lines it was given? Well, the answer is kind of weird, and it has everything to do with the bizarre, counterintuitive nature of high-dimensional space. Let's try to picture this. In low dimensions, like a 2D graph, your data points are all pretty close to each other. They're like people packed into a small room. It's easy to find a spot in between them. But in high dimensions, the complete opposite happens. The amount of space just explodes, and every single data point becomes incredibly lonely and isolated. The space in between pretty much disappears, and all you're left with is this vast, empty void. And listen, we're not talking about some abstract, far-out mathematical idea here. The paper puts a number on it. This whole effect, where every data point is an island, it becomes a near statistical certainty for any data set with more than about 100 dimensions. Just for perspective, a single simple image can have thousands or even millions of dimensions. So yeah, this applies to pretty much everything modern AI does. Okay, to really nail this down, we need one last concept. It's called the convex hull. Now, the easiest way to think about this is to imagine all your training data points are just floating in space. The convex hull is like you take a giant sheet of shrink wrap and you pull it tight around the entire cloud of points. Everything inside that shrink wrap, that's your interpolation zone.
And here's where it all comes together. Step 1. In high dimensions, the volume inside that shrink-wrapped convex hull is microscopically, ridiculously tiny compared to the total space around it. So step 2, when you introduce a new data point, the chance of it landing inside that tiny little shape is practically zero. Statistically, it is virtually guaranteed to land somewhere out in the massive emptiness outside the hull. Which brings us to step 3. Landing outside the hull is, by definition, extrapolation, every single time.
Okay, so if we accept this, that AI is pretty much always extrapolating, what does that actually mean for the future of AI? Well, this discovery forces us to rethink some of the most basic ways we talk about, measure, and even understand artificial intelligence. The single biggest consequence, according to the paper, is that our actual definitions seem to be failing us.
I mean, if we praise a model for good generalization because we think it's doing a good job of interpolating, but what it's actually doing is extrapolating, well then our whole framework for judging how well an AI performs might be built on a totally flawed idea.
This leaves us with three huge implications. First, our classic textbook definitions of interpolation and extrapolation are pretty much useless for describing what AI does in the real world. Second, this thing we call generalization, and AI's ability to handle new stuff, is a much weirder and more mysterious process than we ever gave it credit for. And third, it means we desperately need new theories to explain how in the world AI got so good at this constant act of extrapolation. So you see, this isn't just some minor academic detail. This is a fundamental shift in how we see things. It takes away our simple, comfortable answer of it just connects the dots and replaces it with a much deeper, more fascinating mystery.
And that leaves us with a final and most important question of all. If our most advanced AIs aren't just filling in the blanks based on what we've already shown them, then what are they actually doing? What kind of intelligence is this really? It's a question we thought we were getting closer to answering, but it turns out we might have just discovered how much we truly have left to learn.